A big update, a huge update on our favorite interstellar object. It could be the biggest update in the solar system.
The distant wanderer known as 3I Atlas stunned astronomers as it raced inward toward its closest point to the Sun, or Perihelion, initially flagged on the 1st of July 2025 by the survey telescope network Atlas in Chile. This visitor from interstellar space arrived with a trajectory that was clearly unbound, its orbit hyperbolic, indicating that it was not gravitationally bound to our Sun and had traveled from somewhere beyond our solar system. Before we start, smash the like and subscribe buttons for more updates. As 3I Atlas moved from the cold outer reaches toward the inner solar system, it began to exhibit signs of active transformation. Closer to the Sun, the increasing heat triggered sublimation of volatile ices and release of dust, forming a coma and eventually a tail. These are typical signs of a comet. What was far less typical, however, was the scale and speed of change, and especially the hue that the object began to glow with, a startling blue color. Observations from space-based solar sensors recorded that 3I Atlas appeared distinctly bluer than the Sun. The blue glow is particularly puzzling because comets usually appear red or yellowish due to reflected sunlight off dust grains and organic compounds in their comae. In this case, the blue suggests that gas emissions, not just dust reflection, dominate the visible light. Some researchers attribute it to ionized carbon compounds, perhaps carbon monoxide or even ammonia, undergoing excitation in the comet's coma and emitting light in the blue spectrum. As 3I Atlas reached perihelion at approximately 1.36 AU from the Sun, traveling at a very high velocity, it was already well on its way to making history. The speed, trajectory, and timing combined to make this the third known interstellar object to enter our solar system, after 2I/Borisov and Mai Oumuamua. Yet the recent images and data reveal as many questions as they do answers. The rapid brightening of 3I Atlas as it closed in on the Sun defied expectations. Usually as a comet approaches perihelion, the brightness increases at a moderate rate as sunlight warms up ices and releases dust. But this object brightened at a rate far steeper than typical comets. According to preprint analyses between September and October, its brightness increased roughly as the 7.5 power of its decreasing heliocentric distance, twice as fast as what was earlier observed for this object and much steeper than typical behavior. Beyond brightness and color, the composition of 3I Atlas is revealing surprises. Spectroscopic observations show unusually high levels of carbon dioxide relative to water, far higher than seen in most comets from our solar system. The abundance ratio of CO2 to H2O is among the highest ever recorded. Combined with detections of nickel emission lines and cyanide gas, the chemistry appears distinct from the usual cometary templates. When the perihelion images arrived, showing the glowing blue envelope around the nucleus and the brightening coma, scientists realized that this interstellar visitor is doing more than simply passing by. It is behaving in ways that challenge our existing models of cometary physics. The blue tinge, the rapid brightening, the atypical composition, all point toward processes that are not fully understood. The implications are profound for how we understand not only comets, but also the nature of objects formed around other star systems. One implication touches on the origin of 3I Atlas. The unusually high CO2 content suggests formation in a very cold region far from its parent star, perhaps at or beyond the CO2 ice line in its original system. That would mean that it preserved volatiles rarely seen in solar system comets. This in turn hints at diversity of chemical conditions in star-forming environments. If comets from elsewhere can carry such unusual chemistry, then the range of building blocks available in planetary systems is broader than we often assume. Another implication is for the study of cometary physics under extreme conditions. The fact that 3I Atlas brightened so rapidly suggests that some threshold mechanism might have been triggered as it approached the Sun. Perhaps a latent volatile layer being exposed, or a structural change causing a sudden increase in outgassing. The blue color supports a dominant role of gas emission rather than dust reflection, which may require revisiting how cometary comae evolve when subjected to intense solar heating from interstellar objects with unusual composition. Moreover, the blue glow changes how we think about detecting and observing such objects. Many past comet surveys look for dust reflection signatures, which often yield redder hues. If interstellar comets melt out different volatiles and generate gas-dominated comae, we might need to adjust our observation strategies to capture these signatures earlier. It also suggests that there could be a population of interstellar objects that simply don't light up the way classic comets do and might be overlooked. The perihelion passage of 3Y Atlas also offers an experimental ground for solar system science. As the object passed behind the Sun from Earth's view, spacecraft like solar observatories and planetary orbiters had unique vantage points to monitor its coma and tail development. The interaction of the comet's outgassing with the solar wind and heliosphere may provide clues to how interstellar material behaves in our system's environment. It opens a new laboratory to test theories of plasma-comet interaction, dust dynamics, volatile chemistry, and solar heating effects on exotic bodies. Furthermore, given its interstellar origin, the event presses on the question of how many such objects pass through our solar system and with what frequency. If 3I Atlas turned out to be this active and unusual, perhaps many interstellar visitors go undetected or uncharacterized. The gunshot bright burst of activity may serve as a reminder that interstellar comets could be hiding in plain sight, and that our surveys might need to account for the non-standard behaviors exhibited by extrasolar visitors. There is also a philosophical implication. Each interstellar visitor brings a fragment of another star's system, a piece of cosmic material born in a different environment. 3I Atlas. Glowing blue and acting unexpectedly is a message that our solar system is not isolated. It is part of a broader galactic neighborhood where objects can wander in from afar. Studying them is akin to bringing back a sample from a remote star system without leaving Earth. The images from Perihelion thus mark a turning point. They shift our perception of comets, draw attention to interstellar dynamics, and challenge theories built primarily on solar system examples. They prompt a re-evaluation of volatile inventories, cometary surface evolution, and the influence of extreme heating on small bodies from exotic origins. The glow of blue around 3Y Atlas is not just an optical curiosity, it is a clue that our scientific models may be incomplete. In the weeks around perihelion, the scientific community watched closely. Researchers compared data from solar-observing spacecraft, ground-based telescopes, and planetary assets. The disparity between expected and observed behavior led to renewed interest in modeling of interstellar object injection rates, composition, and surface processing. If 3I Atlas remains coherent and intact as it departs, its outbound journey will offer another chapter of study: how an interstellar object recedes after its closest solar encounter and how the coma and tail evolve in decreasing solar flux. This event underscores the importance of rapid discovery, follow-up observations, and international collaboration. The complex behavior of 3Y Atlas means that no single observatory or spacecraft can capture the full story. Coordinated observations across wavelengths, from ultraviolet to infrared and from optical to radio, are essential. This will set a blueprint for future interstellar visitor campaigns. The discovery of 3Y Atlas in its striking post-perihelion phase also brings forth an era of heightened curiosity about how interstellar chemistry evolves when exposed to the sun's radiation. The blue emissions could hint at chemical pathways unfamiliar to solar system scientists, reactions that may have originated in molecular clouds or around stars very different from our own. When such a body enters a new stellar environment, it experiences an abrupt transition from the frigid darkness of interstellar space to the intense photonic pressure of a nearby star. That sudden shift can provoke energetic molecular transformations, producing ions, radicals, and luminous gases that would rarely survive in more stable conditions. For astronomers, 3I Atlas offers a glimpse into those transient chemical worlds, a window that may only remain open for weeks before the glow fades into invisibility. Even more captivating is the potential that these reactions mimic conditions found in the early stages of planet formation. If this interstellar object carries unique ices or carbon-rich materials, their sublimation and ionization near the Sun might replicate chemical steps that seeded organic molecules billions of years ago. It becomes a living experiment on the chemistry of creation, played out in real time and on a cosmic scale. Observing such phenomena with advanced spectrographs could unravel the complex web of carbon compounds that form in alien planetary systems and determine how life-building materials spread across interstellar space. The allure of 3I Atlas lies not merely in its radiant beauty, but in its symbolic resonance. It demonstrates that our solar system is open to visitors from the depths of the galaxy, and that those visitors can reveal stories no probe or telescope could uncover alone. Its blue light cuts through cosmic darkness like a signal, an unspoken testament that the universe remains full of unsolved mysteries waiting to be illuminated. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas glowing blue after perihelion? We want to hear from you. Thank you for watching, and see you next time.